Welcome to Module 7, Representing Ratios and Rates. This is Lesson 7.1, Ratios. Our essential question is, how do you use ratios to compare two quantities? First, we must define the word ratio. A ratio is a multiplicative comparison of two quantities expressed with the same units. If we break that down to a little bit shorter, that is a comparison of two quantities with the same units. So let's try to break this apart with an example. If we have a bracelet that has 3 star-shaped beads for every 1 moon-shaped bead, and the quantities must have the same units, what are the units in this example? Well, the two things that are similar in this are the words beads. Our units here are comparing beads to beads. Alright? What about terms? What are terms? Well, our definition of ratio does not have the word terms. It is a multiplicative comparison of two quantities expressed with the same units. So let's find out what terms are. Terms are numbers in a ratio. Well, if you think of the quantity of something, how much of something, those are numbers as well. So our terms is another way of saying quantities. So terms and quantities are synonymous. Alright, so what are the terms in our example? What are the terms? Well, if the terms are numbers, then in our example, our terms are 3 and 1. Now, we have not yet written a ratio. We have just defined what will represent our ratio. So we have 3, 1, and beads. So let's figure out how we can write a ratio. We can write it several different ways. For example, if we went to a shelter and the shelter had 5 dogs to every 3 cats, we could write that in the spoken form as 5 to 3. So that's the first way we could write it. The second way we could write it is 5:3. And the third way we could write it is 5/3 to look like a fraction. Alright, so what do ratios compare? Ratios compare part to part, and when you compare part to part, that's the same thing as comparing the beads in a bracelet, where the beads are the part to the whole bracelet. Whoops, too many E's there. So you're comparing part of beads to part of beads, which make up the whole bracelet. So part to part would be the beads. An example of part to whole would be if we had a pizza and we were comparing how much was eaten or left over in comparison to the entire pizza pie. And what about whole to part? Well, a whole to part could be when we compared a recipe, so the entire recipe, to one ingredient, such as in the beet video, when they compared the entire recipe to 1 teaspoon of raspberry jam. Let's see examples of this. If Ms. Dybvig has a video collection, so I have some DVDs, and I have 8 comedy DVDs, 3 drama DVDs, 2 cartoon DVDs, and 1 science fiction DVDs, I want to write the ratio of comedies to cartoons in 3 different ways. Well, first of all, what kind of comparison is this? Well, comedies makes up part of my video collection, and cartoons make up part of my video collection. So this is a part-to-part comparison. Alright, so what are the 3 different ways that I can write this? I can write this as 8 comedies to 2 cartoons. I can write this as 8 comedies, colon, 2 cartoons. Or I can write it as a fraction form as 8 comedies over 2 cartoons. So I'd like you to take a second to notice that each time I wrote a ratio, I wrote my comedies first and my cartoons second. The reason why I did this is because that is how it's listed in the word problem. It says write the ratio of comedies to cartoons. So each time I listed the 8 comedies to the 2 cartoons. Remember, order is super important. So in example B, it says write the ratio of dramas to total videos in 3 different ways. So dramas make up part of my videos, and we're comparing it to the total videos, which would be the whole. So this is going to be a part to whole comparison. So what would that look like? Well, our part is dramas, and we have 3 dramas, and that is compared to the whole. And to find the whole, we need to add up all of the videos. So I'm going to add this real quick in my head. I have 8 plus 2, which is comedies plus cartoons. 8 plus 2 is 10. 3 plus 1 is 4. 10 plus 4 is 14. So that is 3 to 14 dramas to total videos. Another way to write that is 3 colon 14. So 3 dramas to 14 total videos. And finally, we can write it as 3 over 14 and in fraction form as 3 to 14. So 3 dramas to 14 total videos. Remember, order is super important. Let's practice this a little bit more. If we have a party mix and we want to write each ratio in 3 different ways. Well, here we have bagel chips to peanuts. This is going to be a part-to-part comparison. And the first way to write this part-to-part is the bagel chips make up 2 cups, and that is compared to the peanuts, which is 1 cup. So we have a 2-to-1 ratio. Another way to write that is with a colon as 2 colon 1, so 2 bagel chips to 1 peanuts in terms of cups. And finally, we have 2 over 1. That's 2 cups of bagel chips to 1 cup of peanuts. So again, we have kept it part to part, as in bagel chips to peanuts with 2 to 1, 2 colon 1, and 2 over 1. Let's look at the second example. We have total party mix to pretzels. So this is the whole party mix to part of the party mix, which is the pretzels. And so our total party mix makes 8 cups to the portion that is pretzels, which is 4 cups. So that's 8 to 4. We can write it with a colon as 8 colon 4. And then we can write it as a fraction as 8 over 4. Again, I have kept everything in the same order. Alright, let's practice the cheese crackers to peanuts. This again is a part-to-part, comparison. Alright, so what does that look like in terms of numbers? So we have cheese crackers, which is 1 cup, to peanuts, which is 1 cup. So this is a 1-to-1 comparison, or a 1-to-1 ratio. As written as colon, you have 1, colon, 1, or 1-to-1 ratio. And as a fraction, you would have a 1 over 1. So this is, again, a 1-to-1 ratio. Now, in this one, order isn't as important since it's the exact same number. Just know that your cheese crackers to peanuts is 1-to-1. For every 1 cup is 1 cup. Alright, let's take a look at equivalent ratios. Equivalent ratios are ratios that name the same comparison. So we're just making it larger or smaller. This is similar to when we were making the recipe larger or smaller in the beets video. So we'll need to multiply or divide both terms by the same number. So if we have 2/7 and we want to make that a larger number, but still equivalent to 2/7, you would multiply the top by 2, and 2 times 2 is 4, and then multiply the bottom by 2. 7 times 2 is 14. So we have now doubled our original ratio. Well, what if we want to make it smaller? We can take our 8 in 8 over 24 and divide it by 4, which gives us 2. And then you have your 24. If we divided it by 4 on the top, we'll divide it by 4 on the bottom. 24 divided by 4 gives us 6. So our 8/24 would be reduced down to an equivalent ratio of 2/6. Let's look at an example of this. If we make 5 cups of punch by mixing 3 cups of cranberry juice with 2 cups of apple juice, how much of each juice is needed to make 4 times the original recipe? So with our first method, we can use a table. Now, what I would do is I started in my first 2 squares, or my first column, with the original amount. That is 3-to-2. So in my second column, I will multiply the original column by 2. So 3 times 2 would be 6, and 2 times 2 would be 4. When you go into your third column, I would multiply my original column by 3, and that means that 3 times 3 is 9, and 2 times 3 is 6. When you go into your fourth column, I would multiply the original column by 4, so that gives us 3 times 4 is 12, and 2 times 4 is 8. And finally, going into your fifth column, I would multiply times 5. So 3 times 5 is 15, and 2 times 5 is 10. So, what is the amount of juice that we would need to create 4 times the original recipe? So I would go to my 4 times and see that I would have 12 cups of cranberry juice to 8 cups of apple juice. And that is our equivalent ratio. How else could we do this? We could have 3 times 4. Oh, it's not showing up. 3 times 4 and 2 times 4. And multiply over. So, 3 times 4 is 12, and 2 times 4 is 8. We got the exact same thing. Alright, so, using this method here that previous students have called the hamburger method, find 3 equivalent ratios for 8/10 and 5/2. I'll put up my answers briefly. Alright, so here are my examples. See if you can guess how I increased or decreased my equivalent ratios.